Our next step will be to find or estimate the p-value, which is based off of the sample test statistic we found in Part D. Visually speaking, we'll be working with a standard normal curve where it has mu in the middle, and our z-score that we found is 3.81. When finding 3.81 on the standard normal table, we get the p-value of 0.9999. And that shades in this entire area to the left. But what we want to actually find is the area to the right. So what we will do is 1 minus our p-value. So 1 minus 0.9999, and that is equal to 0.0001. But since this is a two-tailed test, we will multiply that by 2 to get our final p-value. So the p-value is equal to 0.0002. Since we have our p-value, we can now move on to Part F, where it says, based on your answers in Part A through E, will you reject or fail to reject the null hypothesis? Are the data statistically significant at level alpha? So in order to reject or fail to reject, we take our p-value and compare it to our level of significance. Since our p-value is less than our level of significance, we will reject the null hypothesis. And just a little trick to remember if you reject or fail to reject that you probably won't hear often in a classroom is if the p is low, reject the ho. Not the most appropriate, but it is something that will help. So since we rejected the null hypothesis, we can say the data are statistically significant. At the 0.05 level. And that's just restating your level of significance. So for Part G, it says to state your conclusion in the context of the application. This is taking Part F, rephrasing it almost, and applying everything you did above that. So we can say there is sufficient evidence to conclude that the average age is different than 25 years old. And this kind of conclusion can be the same for every problem that you do like this. It would be insufficient if you were to not reject or fail to reject the null hypothesis. But this is the same basis for every question. You just rephrase it in the context of your problem.